Hello viewers, welcome to my channel Science to Technology. In today's show, Computer Wednesday, we're going to talk about a Chinese hype of general purpose media interface. So let's dive deep into it. Now, why do we need something like that? Well, reality is we need to connect a lot of things. So we have a lot of problems. And how many things? Well, think in this way: PC to storage, GPU to display, phone to PC, TV to audio video receiver, that sort of things. Basically, we have a lot of consumer electronic trying to communicate to other consumer electronics, and that creates an issue. And this was like exaggerated after 1980s boom in consumer electronics. So things have been bad for a few years, and I'm pretty sure if you are in 30s, you know this basically wiring system. Basically, this is how you knew whether some person is rich or poor. If their TV had three wires, as in yellow composite, red right channel, red right channel, white left channel, yeah, they're poor. If they had five, is like composite system, and then red and left, oh, they have like rich people, DVD people. So, but again, very long ago, like early 2000s. So, a lot of wiring, and again, that's just to connect one device. So this was a serious issue, and early computers were really bad. Like they were bad, as in like they had ports for everything required its own port. So they have been trying, lot of people, lot of companies, customers, government even have been trying to standardize all these things. And again, if you look into Europe and they find different coaxial system for basically transmitting analog audio and video, is simply because of that. It's like government also tried. It's like, hey, let's make this, so standardize it. So it's a problem. It's a genuine problem, and we do not have a one shop solution, so to say. So this is how our 90s started to roll over, so to say. Then we come to the birth of USB, Universal Serial Bus. Now, this actually digested most of the ports that we used to have in backside of the computer. Basically, there used to be a port for keyboard, a different port for mouse, a different port for scanner, a different port for joystick, different port for camera card readers. So all of those slowly got dissolved into one thing, USB. Now, basically dedicated port for almost everything. Nowadays, it does your data, it even does your low power charging and all that. So almost everything. And it over time, as in like right now, if a young boy is born into this world, in his mind, everything has USB already, meaning they will not know a different world where it's like, oh, we used to have a different printer port, a VGA port, a DVI port. Those won't be there. So it worked. And again, all mobile phones have USB-C. Heck, if it's born recently, even Apples have USB-C. Again, thankfully, European Union law, 2025 was the deadline. So it's like, sorry, 2024 end was deadline, where it's like, no, everything has to have USB-C. Laptops will also go away from their custom charging by 2026 end. So in January 2027, we'll all have USB-C laptop charging, PD 3.1. So that happened. Like USB slowly over time in last 20 years digested everything, and now we have USB-C port that does data and power. But while that should be awesome and we should celebrate it, it created an issue. The fact that it has been going through constant upgrade, it created itself an issue, as in there are too many stuff added to your USB system, meaning back in the old days, you had a lot of ports. Heck, there was a port we used to call printer port because it was only found in printers or some routers, basically USB-B port. So we had USB mini USBs, USB-A, female USB, nothing else. It's just like, it was a done sorted deal. But now we have USB, and USB forums started to smoke something bad, and they start to rename things. They launched it and they're like, no, let's rename it. It's like, dude, you don't have Thanos. You can't undo something that you have sold. So let's try to logically name it. So we started from very low USB 2.0. Then we jumped up to USB 3. That was the biggest jump. Like nothing. Whoa. Like USB 3 was so fast that you could actually have SATA 3 hard drive, SSD, or SATA 3 SSD, and full speed can be utilized over USB. That was like, whoa. Like, whoa, like that was the first time external mechanical hard drive becomes a normal thing because it was actually fast enough. Before that, barely transmitting at 20 Mbps, 25 maybe. After that, it's like, bro, put this puppy in and you are getting read-write speed if it was inside your computer. That was like, whoa, 100, 200 even. So that was amazing. But After that, let's call that USB 3, 5 Gbps, 5 gigabits per second, translation 600 megabytes per second, maximum throughput. So that's what you are gonna get. That's the starting point. Then we went to 10 Gbps. Again, nothing changed physically. They just changed the signaling electrically. Then we go above. We go to 20 Gbps. Now they had to add extra conductor. That's why USB 20 Gbps will never be in a USB this sort of port. It does not have the conductor. USB-C has the conductor. So in that, they will only come with USB-C. Then we went to 40 Gbps. But here's the deal. All this thing that we are adding is like, okay, 5 Gbps, 10 Gbps. Be mindful, if you have a cable that is 5 Gbps, it will work for 10 Gbps, hopefully, 99% of the time. 10 to 20, yeah, you can't use, basically, if you have a device for 20, a computer for 20, cable is 10, it will not work because cable will not have the conductors. So you can see like how messy this became. And penalty of that is how much work we want this tiny thing to do is brutal. Meaning we have to put a computer in the chip itself, as in the actual plug has a computer, full-fledged computer. Let that sink in. Like it has a computer. So what does that computer do? Well, that computer takes the power, creates a power supply. That power supply feeds power to ball grid array system that is a retimer chip. Basically, that retimer chips does the signaling because the connector itself is so noisy that if you actually try to digest data at 40 Gbps, it will not transmit very far. So it digests the 40 Gbps transmission and then creates a clean signal that goes through coaxial cable. It's no longer conductor. It has to be coaxial. Otherwise, it will have very poor, basically if it's a very short cable. If you want like even 1 meter cable, it has to be coaxial. And God help you if you want to do that with a 40 Gbps cable. So it has to have a retimer chip, and on the other side it also needs retimer chip, so it can actually decode the signal without being overwhelmed by noise, and then it will connect. So it created a lot of error. That's like your modern Thunderbolt cable or modern USB cable, and yes, they are almost commingled at the same thing at the USB 4 standard. They are ludicrously costly. And be mindful, that's just for data. On the transmission end, or like your computer or your smartphone, they also have extra what you call options. So simple option is there, power delivery, and people were very smart, so they gave a dedicated pin for power delivery. So that's a very isolated system. But other pins, they're like, hey, what if you want to send a video signal over that? So thankfully, I do have a smartphone that Samsung S series. Almost all S series have that ability, meaning SoC actually sends display signal over USB-C directly, wire to wire. So it's not like a protocol change. It's not changing the protocol. It's directly going there. It's very crisp. Like if you try to connect like my mobile phone to this TV and actually play games on it, very low latency. Like latency is so low, it's literally playing on the hardware itself. So that's also there. But penalty, now the remux chip is like, okay, these wires are for data, these wires are for display, these wires are for return display. Yeah, it's a messy thing. So it created a very costly scenario. And the worst part is they are seldomly utilized. Like it's so shocking to me that there are very few smartphones in 2025 that have USB-C even on a basic level, as in, does it have 3.0? Most of them don't. And I'm talking about like, 500 Mbps. Most don't. Heck, Samsung only goes to 500. Apple started to jump to 10 Gbps because they wanted like, ProRes directly recording on SSD. That had to be done that way. There was no other way. So they did that, thankfully. But everything else is still stuck at 5, and 99% phone still at USB 2.0, meaning you cannot back up it, even though you let go of the option of SD card. That's frustrating. Display output, which I love, that's a very cool, useful function. Yeah, and be mindful, all SoCs have that, all of them. Companies are like, nah. So we have a very expensive system and seldomly utilized. How do I know that all SoC has that? Arduino released a SoC with Qualcomm device that had that, and it was 2000 rupees. It's a chump change device. Arduino chump change device, and it has like USB-C full spec, as in 3.0 data transmission and display output network, and basically you connect a hub, the end. So USB solved a lot of problem, but its own success is becoming an issue. So that's why you have like, port logo and power logo differently, as in like, is it 60 watt? What does 60 watt mean? 60 watt means there is no IC for power. What does 240 watt means? It means it has a power delivery 2.1 IC. If it does not have that IC, if no IC, it will only go to 3 amps, 24 volt. If it has some IC, it will go to 24 volt to 5 amps. If it has 3.1 IC, then it will go from 24 volt to 48 volts and 5 amps. And like, okay, why the heck it's 5 amps? They decided that it would be too big of a conductor requirement to go above 5 watt. And why 48 volt? You cannot go above that. It goes to 50 volt, then it becomes what we call high voltage, as in if a child chews through it, there is a very good chance it will get shocked. So 48 voltage design is the upper limit, is like, it's the upper limit of low voltage, as in like human safe. So that's maximum. So as of now, USB-C can only go to 40 watts, because the only way to bypass that would be to add more current, and again, that will require another IC if they had to do that. So you can see, like, it's a very expensive, very messy process, even though we are reaching the zenith, where it's like one port to rule them all. We are not there yet, so to say. Now we come to HDMI. Now HDMI came into the market in at like early 2000s, simply because digital video started to become a thing. Blu-ray started to come into the market, and they needed a way to connect to other things. You could do composite full HD, but it was interlaced, like comb kind of video, interlaced, not progressive. So HDMI was brought into the market by 2003, and DisplayPort entered the market in 2006. DisplayPort was directly firing missile at DV ports, and it boomed DV port. Like DV port kaput so quickly, it was like shocking. You can find VGA still, you cannot find DV anymore. It's like VGA, DisplayPort, DV got kaput. So HDMI can do everything that market asked of it. What did market ask? As in, the people who are with the money, they wanted copyright protection, because once you are starting to reach Blu-ray, the quality of the Blu-ray material is almost cinema level. I'm not joking, like actually cinema level, because be mindful, most cinema till recently was only mastered at 2K, which was little bit more than full HD. So you are getting a copy which has like uncompressed audio, very good frame, as in like all frames are there, and each frame is full HD, and they developed a new compression format known as H.264 for Blu-ray. So the quality of that puppy was good, and be mindful, it is so good that I'm watching Hitman. I have Blu-ray of that. On this TV, it still looks good. Like, you'd be shocked how good that is. So they wanted to make sure that people just can't Control-C, Control-V that file. So copyright protection, as in the integrated circuit that is on the device, as in transmitting device and receiving a TV and Blu-ray player, have encryption handshakes. And hackers were like, bitch, please. They hacked it. It was funny. So copyright, but again, they're like 2.1 encryption, 3.1 encryption, all that. There is a battle, and it's like frustrating for consumer, because it's like, I am paying for it, and why you are saying that it won't work on a device I'm paying for it? Just because some hacker can hack it, it's like, of course they're gonna hack it. It's like, it frustrating. And if you like why HDMI sometimes misbehaves, 99% of the time it's because of that encryption layer, and it's frustrating. Blame the copyright holders. Then we have audio. So instead of having 5 wires in a quality TV, you will have 1 wire, and it will also transmit audio. And this time they like flexed on the audio, like full high bitrate audio. And then somebody was like, hey, what if we send audio? It's like, why would you want to do that? For example, this TV has Apple Play, so to say. So I can watch Foundation in this, cool, awesome. But this is a OLED. So while the display quality GG, Dolby Vision GG, the audio is kaput, it's useless. So I have to wire basically audio. How would you do that? No problem. This can send audio out over the same HDMI cable. So that was done. So audio has two-way pathway. Not only it can send, it can also receive. So that's a really good upgrade done into that. And they introduced 3 sizes into the market. So we have type A, decent size, micro, and then we have mini. I have no idea why these 2 ports exist. Again, somebody said like, and there was one Nokia phone that had a micro HDMI. And again, even my Canon 800D has micro HDMI. And then mini, the super tiny mini, that used to be there in all cameras. People hated it because it breaks if you look at it. It has 20 pins in a USB-C form factor. Yeah, it just kaputs itself very quickly. It's like, it was very fragile, very useless. Thankfully now even all consumer cameras also, they have switched to full size HDMI. So that's the good part, and it does not require integrated circuit. This is one thing that they designed from day one. So it has almost the raw data, as in red channel, that's the red color that you see, green channel, and the blue channel, and it goes to the IC on the device, and it decodes it into red, blue, green, and a timing signal. So because again, it was designed from day one as a video output, it has a really good unfiltered, like da, and that's why it requires stupid numbers like 40 gps. Why the heck you have 40 gps? You rarely have any movie file that is 40 gps. Simply because once you decode a video file, it becomes bonkersly huge. Once you decompress all the basically compression layer, you throw that away. You actually decompress it. All the layers that you have to frames that you have to generate. Once you generate it, now it's a big file. Now your gpu decodes it into rgb value. Yeah, that pipeline is huge now. So even at 4K, that pipelines become bonkersly high. That's why it needs like 40 Gbps. So this can handle that. And it also has a clock signal independent. So it's very robust, simple. Connector is just a connector. There is no retimer IC. Unless you are doing some very long distance or some very finicky thing, you do not need any integrated circuit on the cable, even as high as HDMI 2.0 or HDMI 2.1. Although long distance may introduce it, may. I've not seen that many, but again, generally if they're like long distance, they just go to optical transceiver at that point in time. Duh. But very successful system, but you have to pay royalty for this puppy. As in TV manufacturer, let's say this is LG TV manufacturer, they have to put 4 HDMI port, they have to pay $1, let's just say, $4 to the license of HDMI holders. Again, that's the reason why monitor companies, they do not give you even one HDMI. It's expensive. They have to pay. And again, you might like, is it a big deal? Yeah, when you are making millions of them, it's a very big. Even 100,000. Who would like to pay $100,000? So DisplayPort, and you're like, okay, why the heck DisplayPort did not replace HDMI? Yeah, it could have. It could have. Unless I think now it can only happen if European Union is like, now all TV must support it. Then over time people will switch. But is that industry momentum? And again, we are not going to create any new format, physical format anymore. So the interface change is no longer needed. So DisplayPort is like, it's going to be a very big deal for computer industry, but not for TV. TV is like done. And again, most of TV, even this TV is like reaching a point where it's like, this is going to be its own device. It has its own smart TV. It is going to have its own internet to content, and then content will only send out audio. So why would they switch? And again, it will require a lot of tooling and expenses and all that. So HDMI. Now we come to general purpose multimedia interface that China is claiming. So it's a Chinese developed interface which is supposed to replace 2PUPI, which is HDMI and other connectors like USB-C. And I lost interest the moment I realized it has 2 ports. It is going back to the old USB days where you had 2 types of it. Now let that be very clear. They are independent, as in this is dual link, that is single link. Although if you look at the port design, they are not compatible. USB 3 people knew that. They designed the port to be intercompatible. As in, if you had USB 3.0 cable and you had USB 2.0 port, you can still plug it. This will not work in this. So I lost half of the interest just there. Like, you have 2 ports and you are designing, we're going to make one universal. It's like, you have 2, make one. So that is an issue. And the Type-C type is Type-C. It's literally Type-C. It's nothing else. It's just, at the best I could say, it's like changing the handshake. Nothing else. It's exactly the same. The hardware is the same. The pin is the same. Most likely the timing IC would be the same, because again, while China is big, they're not that big that they're gonna invest trillions of dollars that it takes over the years to create a new infrastructure. And again, most of the timing IC is coming from somewhere else. Some are coming from PCI Express, some are coming from fiber interlinks and all that. So the retimer chip is already being made for server industry. You do not want to redesign it from scratch. So most likely it has the same thing. Of course, I can easily see some handshake signature difference. Like how Nintendo is effing the customer now. They're like, hey, we're supposed to have USB-C. You're supposed to connect a USB-C hub and it should work. But they're like, what if we F the customer? We change the handshake so we can F them. So that's what they are doing. And they're saying we have 50 partners that have signed on to it. And the only partner that has big name is TCL. And I'm like, it does not have Sony. It does not have Samsung. What the hell does it have? Like realistically, like it does not have European companies, does not have American companies, does not have Korean companies. My man, this compared to how big the HDMI consortium is, like that's 500 company consortium versus 50. And only 2 or 3 of them are big. So it's like, it's not that big of a flex. Like RISC-V association has more partners than this. So this is not good. And be mindful, it does not solve any new problem. It's like, okay, what is the problem in HDMI? If you noticed a problem, solve that problem. Like, let's just say HDMI is very, short distance cable. Are you increasing the distance list? No. Then what was the point? So let's just say USB-C. USB-C is expensive because it now requires coaxial cable, retimer chip. So it's very expensive. Are you changing that? No. what are you changing? Like what exactly you are changing that is worth this hassle, so to say? Because again, at least DisplayPort had the luxury for panel manufacturers. Like, hey, I'm gonna, for TV, I have to deal with HDMI, but if I'm using the same panel for monitors, I only have to give them DisplayPort. It saves them money. What are this gonna do? It's like save money. It's like DisplayPort is there for that. So it does not change anything. The only reason I can say is like Chinese governments, like we do not want to pay the royalty to HDMI. Other than that, there is nothing. Now, is that royalty big enough deal? Short answer, yes, but not that big. Like in proportion, it's not that big a deal. Yeah, it's $1 million, but $1 million to $1 billion corporation is like, bruh, the gap between million and billion is still $1 billion. So it does not make sense. And you are giving almost this, it's like, oh, 240 watts, cool, awesome, that's exactly USB 3 power delivery 3.1. And it's like, oh, 480 watt, it's, you have twice the thickness. Most likely you just copy pasted the same thing. You just like tweet, it's the same thing. So generally it does not. And again, they're showing we are working from 2019, 2021, 2022, 2023, 2024, 2025, we're gonna have devices. I'm like, it's like, again, there are a lot of proprietary connectors that are still being used, but they are not that logical anymore. So this was like very underwhelming, so to say, very underwhelming. So what can we expect in the future? Well, here's the, all the connectors that you see right now, they still have the philosophy of 90s, as in send the signal over copper. And again, I do not blame HDMI people, because again, they started the work. Even if the port came into the market in 2003, the most likely they have been working from 1990s on that. So conductors are great for actual power transmission. If you want your mobile charging, you're not going to do that over fiber. You're going to do that over copper or aluminum. So conductor is good. But here's the deal. We have reached a point where signal frequency, the megahertz that we are using, it's so goddamn high. Like, if I'm not mistaken, HDMI is at 350 megahertz. And other things are so goddamn high frequency, it's reaching the limit of the conductor itself. And again, the best people for dealing with this is networking people. The first thing they did, throw away the conductor. They jumped to fiber, and they jumped very early on. Why? They were reaching that high frequency. So fundamentally, like, copper should only be used for power, and for signal, you have to use fiber. And then you will get what we call stable, cheaper. And be mindful, fiber is cheaper. Let that sink in. So if I give you like, okay, this conductor, data conductor is 10 meter. 10 meter of fiber versus 10 meter of coaxial cable, yeah, you'd be shocked how much. And be mindful, copper will not even work for 10 meter. So if you're like, hey, I'm gonna send a 400 GPS one node connection to another node connection, you can't do that over copper. Like, you just can't. The frequency is like, yeah, that copper block will act like a nope. So fundamentally, fiber is much better and cheaper interface. And if you want to design a new interface, that's what I was thinking. That's what I was hoping. It's like they're going to do something like that. This is used in medical industry. This is used in oil and gas industrial industries. So the idea with these connectors are, they are hybrid connectors, aka they have power pins and fiber, meaning you do not have to worry about anything. Of course, there will be upper limit of voltage, upper limit of current. What about data? Nothing. Data is limited by you, as in like the ports on they can switch, as in like the same fiber that people laid down in underground in 90s for mobile tower, that was 1 Gbps. They swapped it, as in they did not touch the fiber, they just swapped the SMP modules from 1 Gbps to 10 Gbps. And then somebody came up like, hey, what if we have prism, as in what if we cross multiple channels into same fiber? Boom. Somebody came up with a ring laser oscillators. It's like, boom. Now you can, same fiber, by the way, untouched. Of course, fibers do degrade and break over time. Mostly the primary issue is breaking over time. But you can have the same fiber that was 1 Gbps, now 800 Gbps. Especially for short distance, it's not even an issue. Unless you are talking about 100 kilometers, then they're like, bro, we have to choose different kind of fiber. So that's how industry and medical science is dealing with this. It's like, just have copper and fiber. And again, the copper also is done very smartly. So they have 2 primary conductor and 2 handshake conductor. Exactly like how USB-C has power rails and handshake rail. Same with this. So this would have been the future connector that I was hoping that China was designing. That's like, hey, buy this cable and forget about it. The end. Like, of course, it will have a current limit, but let's just say it was designed 480 volts. 480 watt day one. Like, they are designing it from day one. Of course, ideally it's consumer electronics, so you do not want high voltage. So let's say they designed it for 10 amps. Done. It's a 10 amp conductor limited to 480 watt. That's more than enough. That's half kilowatt almost. Done. Go home. Sir, what about the data? Don't worry about it. We keep increasing it, the fiber will remain the same. As long as the fiber is single mode fiber, you do not have to worry about it. This, again, Japan also made this sort of system for their army systems, military electronics. It's like, hey, we have coaxial, and the outer sheathing is the positive, outer sheathing on the other is the negative. I'm like, that's clever. 2 in 1. So you have power and fiber. This, and be mindful, this is what was the original dream of Intel team that was designing Thunderbolt with Apple. So they wanted that, like fiber, but be mindful, they were a bit too early. The fiber electronics were not that cheap. They are cheap now. So I can easily see somebody clever in the future can just like, hey, what if we give this USB-C kind of geometry and just forget about it? It's like, sir, what is the GBPS? Don't worry about it. There is no retimer. There is no, oh, this lane or that lane or conductor count or nothing. Just shut up, connect it, go home. So that's what a future I want, I'm hoping for. So this was my presentation on basically China's new hype. Hopefully you have liked it, learned from it. In that case, please hit the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike. Press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free. And as always, thanks for watching.